When working with access control lists in Spring Security expects us to have a default schema that has been structured to work with the access control list features in the framework. This schema is contained within the ACL underscore schema.sql file, which you can find within your working files directory. At the moment, we have the H2 schema. Now, there's different flavors of this ACL schema out there. So if you are working with a different type of database, you can consult the Spring Security documentation, and within that reference documentation, you will find the appropriate SQL that fits your flavor of database. Looking at our ACL underscore schema.sql file, we see that there are 4 tables being created to support the ACL functions within Spring Security. And we're just going to walk down through each one of these tables and talk a little bit about them. The first table we encounter is the ACL underscore SID table. Now, this table is used to store information about the principals or authorities within our system. So it serves a dual purpose. You can store in some sort of role or authority, or you can store an individual principal. The first column is just an arbitrary ID, and we see we're referring to a generator within our database to create this. This second column is a Boolean to indicate whether or not this entry is for a principal or an individual user. If this were a role or an authority, we would set this to false. If this were an actual user, such as like K Bowersocks, we would set this to true. Next is the SID column, and that is the security identifier. And this is an important column because it's basically the key we're going to be using for our principals throughout the ACL table structure. In our case, we're going to be using the user name of our principal, and we'll be storing that within the SID column. Next, we'll move on to the ACL Class Table. And this table is pretty simple. It consists of 2 simple columns. One is a big integer that just has basically a surrogate key within it. And then the other has this class column, which is of type varchar. And what we want to put in this column is the fully qualified class name of the objects in our system that we are going to require specific authorization to access. So in a sense, this is just storing a list of the types of objects that we want to protect using an access control list. Next, we have the ACL underscore object underscore identity table. This table is a little bit different and a little bit more complex. Within this table, we are storing information about the actual object instances that we're going to be protecting. So in the ACL underscore class table, we're storing the types we want to protect, but then within the ACL underscore object underscore identity table, it's the actual instance of that class and that type. And we see it has a surrogate key of ID. And then the next column we see is the object underscore ID underscore class. And that's going to reference our ACL underscore class table so that we know the type of the object that we are protecting via our ACL. Next, you will see the object underscore ID underscore identity column. And this is just the primary key of that object instance that we are protecting. So for example, within our application, we're going to be protecting the appointments. And the appointments all have an appointment underscore ID column, which serves as their primary key and their unique identifier. So we're just going to enter that value within the object underscore ID underscore identity column. The parent object column is used to link to another object within the hierarchy that would be the parent for this object. The owner SID is used to establish ownership of this object. So we would be linking back to our ACL underscore SID column using that SID we have established for our user. So for something like an appointment, it might be K Bauer socks, or we had JA Doe or Joe Doe. So we'd be pointing to those keys which we're using to identify users as defined by our ACL underscore SID table. The final column is just the entries underscore inheriting column. And we normally set this to true to allow for any sort of inheritance. The final table we'll use is the ACL underscore entry table. And this table contains all of our access control entries, or ACEs for short. An ACE combines a few pieces of information to basically establish a role to access a particular object. First, we provide the SID for the principal that we are trying to determine whether or not they can access a particular object. Then we provide the object identifier within our ACL underscore object underscore identity. So now we're pointing at a specific object and we know whose roles or permissions we're defining. And then we specify an order. This is just an order of precedence. And then within this, we also specify a mask, which is going to define whether they have certain permissions, such as read or write. We'll talk a little bit more about the mask when we put some values into these tables. The next three columns are normally always set to true, just so we can have some auditing and other features within the Spring Security ACL mechanism. So just remember, the ACL entry really ties everything together, because we define what permissions a given user has on a particular object. So we have the object, the user, and then this mask, which is really defining their fine-grained permissions on that object. And we can also use this for groups. So our SID could actually refer to a group, a role, or an authority. So let's take this configuration and we're going to select everything. And now we're just going to move it over into our init.sql file so that it can be used by our application. And I'm actually just going to add this right before our insert statements. So just place that DDL within your file and save it. And then you can go to the project. And we're just going to run this on the server quickly to make sure that we have no SQL errors. So I'll just go to run as, run on server. We'll deploy to the server and run. And now if we go to our console, we can watch to make sure we do not receive any SQL errors. So our SQL was valid because we don't see any errors within our console. So we have set up the schema to work with access control lists in Spring Security.